Hey guys, so in this video we're going to talk about how to solve equations where we have variables on both sides of our equation. So that means we're going to have x's on the left side and the right side of our equal sign. Usually we just have them on one side, but so we're going to see how to put them together to solve those kind of equations. So if you have a variable on both sides of the equation, we're going to be using a lot of the additive inverse to get the variables on one side. Okay, so you know how when you have a number on one side of your equation and you have to use the opposite operations to get rid of it? We're going to be doing the same thing with variables so that we can get the variables on one side of our equation. For our first example here, we have 3x is equal to x plus 8. Okay, so the first thing we're going to do is we want to get the variables on one side of the equation. So we have variables over here and variables over here. So the first thing I did is I retyped it. So we have 3x is equal to x plus 8. So we want to get this x over to the other side. So we have a positive 1x, so to undo it, we're going to subtract 1x from both sides of our equal sign. Just like we were doing with numbers, we can do that with variables. So this x is actually going to cancel out, right? X minus x is nothing. It just cancels out. It's the inverse. So then on the other side, we have 2x because 3x minus x is 2x, and then this 8 carries down. And here we just have a one-step equation, right? We want to get rid of this coefficient of 2. It's being multiplied times our x. So to undo it, we're going to divide by 2 on both sides. You can even see my division lines there. So we're going to divide by 2. Again, our 2's right here are going to cancel out. And I have x is equal to 4. Because 8 divided by 2 is 4. Okay, again, just like with our other equations, we can check our answer. But this time we have x's on the left side and the right side of our equation, so we have to plug it in twice. So if you're looking at our original equation, you'd have to do 3 times 4, which I put in parentheses, is equal to, instead of x, we're going to plug in 4 again, 4 plus 8. So then when you solve both sides of your equal sign, they should be equal to each other. Well, 3 times 4 is 12, and 4 plus 8 is 12. So our equation checks out, right? We got the same thing on both sides of our equal sign, so our x must be correct. For our second equation, we have 3x minus 2 is equal to negative x plus 4. Again, the first thing we want to do is get our x's together on one side of our equal sign. So I wanted to get rid of that minus x on the right-hand side, so what I did was I added x to both sides. Since this is a negative x, we're adding x to cancel it out. Okay, so again, those are going to cancel. We would be left with 3x plus x is 4x, and we still have this minus 2, nothing canceled that out, right? And equals 4, because that's the only thing left on this side. From here we have a two-step equation. We want to get our numbers over to the other side. So this minus 2, we're going to add 2 to both sides, because that's the opposite of minus, right? So these 2's are going to cancel out. We'd have 4x is equal to 6, right? And now we have a one-step equation. 4 is being multiplied times x, so to undo it, we're going to divide by 4 on both sides. And when we do that, we get x is equal to 6 over 4, but that simplifies to 3 over 2 if you divide the top and the bottom by 2, which you can leave your fraction like this, or you can divide it and give me the decimal, which is 1.5. Or you could have written it as a mixed number, which I didn't put on here, but that would be 1 and 1/2. Any of those answers is fine. When we're checking it though, it might be easiest to put into the decimal form so that you can just plug it right into your equation. So if you look at our original equation, we're going to have to plug in x here and over here. Okay, so let's see what that looks like. 3x minus 2 would become 3 times 1.5 minus 2. On the other side, we had a negative x, so we're going to put that on there. So we have negative, and then 1.5, and then plus 4. So on both, this side we're going to have to multiply. So 3 times 1.5 is actually 4.5 minus 2. This we can drop our parentheses, it's just negative 1.5 plus 4. Then when we subtract here, we get 2.5, and when we add here, we get 2.5, so our x is correct. It is 1.5. For our third equation, we have 4x minus 10 is equal to 7x plus 8. So again, we want to get our variables onto one side of our equal sign. So I rewrote my equation. I have 4x minus 10 equals 7x plus 8. So then to get our variables on one side, I actually decided to move it over to this side this time because I just wanted my variables to be positive coefficients. So if I figured if I subtract 4 on both sides, this is going to give us a positive 3x, and these are going to cancel out. So it doesn't really matter which side you move it to. Like, I could have subtracted 7x from both sides and gotten a negative x on this side, but I just want to keep my x's positive. But you could do it either way, and you will end up with the same answer as long as you did it correctly. So 4x minus 4x is nothing, right? And then we're going to have negative 10 on that side. 7x minus 4x is only 3x's, and then we have plus 8. So then from there, we have a two-step equation again. Remember, anytime we're solving an equation, we want to get x all by itself. So once we've moved our x's to one side of the equation, you have to get rid of everything else that surrounds that x. So we need to get rid of this plus 8. So we're going to subtract 8 on both sides of our equation. Okay, when I do that, my positive 8 and my negative 8 are going to cancel out over here, and I just have 3x on the right-hand side. On the left-hand side, negative 10 minus 8 is negative 18, and I solve my 3x. And then from there, I have a one-step equation, right? We need to get rid of this multiplying by 3, so the opposite is dividing by 3. Again, these 3's are going to cancel out. Negative 18 divided by 3 is negative 6. So x would be equal to negative 6. When we check our answer, we're going to have to plug in negative 6 on both sides of our equation. And remember, we always plug it in with parentheses so that we remember to multiply. So when we check it, 4 times negative 6 minus 10, okay, so we plugged in that negative 6 there for x, is equal to 7 times negative 6, again we plugged in negative 6 for the x, plus 8. Okay, and so we're getting that from our equation up here. It's the exact same thing we had, except for x's, instead of x's, we're plugging in negative 6. So then 4 times negative 6 is negative 24 minus 10. 7 times negative 6 is negative 42, and then we solve this plus 8. So then both sides of this equation are going to be equal to negative 34. Negative 24 minus 10 is negative 34, and negative 42 plus 8 is negative 34. So we did it correctly, right? If we plug in our x on both sides for our variable and we get the same number on both sides of our equal sign, we know that we did it right. Alright, I know that these seem like there are a lot of steps, but these are actually more straightforward when it comes to variables on both sides of our equations. Sometimes we're going to have to solve more complex ones, which we're going to get to in a second. But here are the steps that you need to follow. Okay, so first you're going to distribute always. Okay, there's a lot of equations where you're going to have to distribute, and so you might have to do it once just on one side of your equation, but you might actually have to do it on both sides of your equation. So make sure you're looking out for all those distributive properties. Okay, those always come first. Then you're going to combine like terms. Okay, and sometimes you're combining like terms that have variables and sometimes it's just numbers, but you always want to combine things on one side of your equation to make it easier so that you're not adding and subtracting multiple times. Then you're going to get all your variables to one side of your equation. It doesn't matter which side, it could be the left or the right as long as they're all together on one side. Okay, and then after that you're just going to solve like you were doing, 1 or 2 step equations depending on how complex the equations were. Okay, so distribute, combine like terms, move variables to one side, and then you're going to solve. Okay, there's some more for us to try. So this next one, we actually have to do the distributive property. Here we have a negative outside of our parentheses, so we're going to take that negative and multiply it inside of our parentheses. So after we distribute that negative, negative times x is negative x. Negative times negative 4 is positive 4. Because remember, this is like a negative 1. If you can't see that number, it's just a 1. So negative times negative, positive 4. Okay, and then we still have this minus 7 over here, and that didn't change at all because the negative is only being distributed to the stuff in the parentheses, not this number on the end. Okay, so then this side we just kept the same for now, 3x plus 10. Now, after we've distributed, we have to combine like terms. And so on our left-hand side, we can combine positive 4 and negative 7, right? And so when we combine those, 4 minus 7 is negative 3. So we have negative x minus 3 equals 3x plus 10. Okay, now we have to get our variables to one side of our equation. So we have variables here and variables here. We have a negative x and a 3x. So I'm actually going to add x to both sides to get those to cancel out. And 3x plus x is 4x. Okay, so we have negative 3 equals 4x plus 10. Now we have a two-step equation. So to get x all by itself, we have to get rid of this plus 10 and the 4 coefficient. So the opposite of adding 10 is subtracting 10, and again I have to do it to both sides of my equation, so we're canceling that out. Negative 3 minus 10 is negative 13, is equal to just 4x. And then we have to divide by 4 to get rid of that coefficient. So we're going to divide by 4 on both sides, and x is going to be equal to negative 13 over 4. And I just left that as a fraction so that I didn't have to do that extra step of dividing in my calculator. Okay, if you know it's not going to divide nicely, just leave it as a fraction. Negative 13 over 4. Okay, we have another equation. In the middle, we have negative 2 minus 6x minus 7 is equal to 10x minus 1. So the first thing I do is look for my distributive property. I don't have any parentheses here, so I must not have any distributive property to do. So instead, the first step we're going to do is combine like terms. Negative 2 and negative 7 are on the same side of the equation, so they can combine together. And so we're going to have negative 6x minus 9, because those are both negatives, so they combine, is equal to 10x minus 1. So now we have to get our variables on the same side of our equation. So we have a negative 6x and a positive 10x. So to get rid of this negative 6x, I'm going to add 6x to both sides. When I do that, these x's cancel out, and I've got negative 9 is equal to 10 plus 6 gives us 16 x's. So I've got negative 9 is equal to 16x, and then I still have this minus 1 over here. Okay, now I have a two-step equation, and I just want to get my x all by itself. So I'm going to get rid of this minus 1 first by adding 1 to both sides. So then our 1's are going to cancel out, okay, and I have negative 9 plus 1 is negative 8, which is equal to 16x. Then this is a one-step equation. We need to get rid of this 16 in front of the x, so we're going to divide by 16 on both sides. Again, those 16's are going to cancel out, and I have negative 8 over 16 is equal to x, or that's also equal to negative 1/2, right? We can divide the top and the bottom by 8. Okay, I'm not checking my answers here, but if you wanted to, you could take your answers and plug them back in for x and make sure that you are doing things correctly, right? You would just have to make sure that this side of the equation is equal to that side. Okay, our last one that we're going to do together is negative 2 plus 3 parentheses negative 3x minus 5 is equal to 6x plus 13. So again, we're going to look for distributive property first, and we actually do have a distributive property here. Okay, we're going to distribute this 3 to everything inside the parentheses. So we're going to keep this negative 2 out in front, but then 3 times negative 3 is negative 9x's, 3 times negative 5 is negative 15. So now that we've distributed, we have nothing to do on this side yet, but we can combine like terms on our left side. So negative 2 minus 15 gives us negative 17. So we'd have negative 9x minus 17 is equal to 6x plus 13. Now we want to make sure that we get our x's on the same side of the equation. Okay, so what I did was I took my 9x and I added 9x because it's the opposite of subtracting 9 or minus 9, and these are going to cancel out. And I'd have negative 17 is equal to 15x's plus 13, right, because 9 plus 6 is 15. And now we have a two-step equation. Again, we're going to get this x all by itself, so we need to get rid of this plus 13, and the way to do that is by subtracting 13 on both sides. Our 13's are going to cancel out, and I've got negative 17 minus 13 is negative 30 is equal to 15x. So then to get rid of that coefficient of 15, which is being multiplied, we're going to divide by 15. So then negative 30 divided by 15 is negative 2. So here our x is equal to negative 2. And again, if you wanted to, you could go back and plug it in for the x here and the x here and use order of operations to solve on both sides to make sure that your x is correct. Okay, on the back of this page, there are some for you to try. Okay, at the bottom, there is an answer key. Okay, so please get it checked with me before you move on, but use your answer key to help you to make sure that you're on the right track.